I've got here a bunch of logs, and I want to contract all of these back, put them all back together into one big old log. And it works the same way as expanding logs, except we're going the other way. So let me start with the powers, because that's the easiest to do. So I want to reverse engineer what we've been doing with expanding logs. So with expanding logs, we were bringing the powers down out in front. So now what I'm going to do is take the number being multiplied out front and then turn that into a power. So if I do that, I'm going to get log x plus the log of y squared plus the log of z cubed. And now it's pretty simple. There's just additions. All of these are going to be multiplied back together. But I'm going to go through it step by step just for anyone who has trouble seeing that. But it's pretty simple now. After people get used to it, they can do these logarithms very, very quickly. But I'm just going to do them step by step for now. So I'm going to do the first two. If I multiply these first two together, or I contract them, however you want to call it, this will become xy squared plus the log of z cubed. And then we repeat this process again for the final step. And it becomes log of x y squared z cubed. And it has become 1 again. And that is the answer. So let me do a couple more. Do one with some subtraction. So subtraction is going to be the part that's going to mess people up. So let me do 1/2 log of whatever x minus log y plus log of z. So first I'm going to do the powers, because it's my favorite. It's log of, and this can be written as the square root of x, or x to the 1/2. So let me write this up here. So the square root of x is equal to x to the 1/2. Some people may prefer to write out in exponent form. I personally prefer the exponent form. I don't like writing radicals. I always draw them badly. But I'm going to write it like this for now, because people are more accustomed to seeing it this way for now. So I've distributed that power, and there is still this minus log y plus log of z. And now I'm going to describe a very common problem, or a very common mistake that people make. And it really comes from expanding out logs. People will want to write this as minus log yz. And this is wrong. Let me do that in red to emphasize its wrongness. This is wrong. And to avoid a mistake like this, I really advise that people do the addition first and then do the subtraction. And the reason it's wrong is just because you've done it wrong. There's not really, if you were to add these together, or if you were, you need to think of this as log z minus log of y. And this would be equal to the log of z over y. And the reason that people get that wrong is just because of the order it's in. That's the only reason. So what I would recommend doing is reorganizing it. So let me reorganize my equation and put all the addition first and then the subtraction. So if I reorganize my equation, it's going to be the log of the square root of x plus the log of z minus the log of y. And now people are less likely to make that kind of mistake. So if I do this addition very quickly, this is the log of the square root of x times z minus the log of y. And then if I do the subtraction of logs, this becomes the log of the square root of x times z over y. And this is the correct answer. So that's a tip definitely that I would recommend when learning it, because I can certainly say for myself that when I learned this in Algebra 2 in high school, I got that wrong quite a few times. And it really is just, it's just because of the order it's in that people make that mistake. So let me do one more that's a little bit tricky. We can't do a problem. We can't just do problems and not have tricky problems. You gotta have a tricky problem. So let me do 3 times the log, whatever, we'll do base 5, just to change it up a little bit. 3x plus 1 plus, nah, we'll do a minus. We'll do a minus, and we'll do about 2 log base 5, 2x minus 1, we'll do another minus log base 5x. And this is definitely a problem that will trip up a lot of people, and I'll explain in a bit. The first thing I'm going to do is just get rid of these powers. So this is going to be log base 5, 3x plus 1 to the third, minus log base 5, 2x minus 1 to the second, minus log base 5 of x. Now what I'm going to do is go in order. I'm going to combine these two terms first. Some people might want to try to combine these two first, and I'm going to not recommend you do that because of the problem that I'm going to show you up ahead. But once someone has a lot of experience in doing it, you can just combine all this in one step. I mean, that's what I would do, but when you're learning, you're going to make a lot of mistakes. So I want to combine these two first. This is going to be log base 5, 3x plus 1 cubed, 2x minus 1 squared, and minus log base 5x. Now here's a mistake that people are going to make overthinking stuff. Or it's not really overthinking it, they're just, I don't really know how to describe it. Let me just describe the error. Let's say I want to combine these two right now. And in fact, you may make this mistake right now. How would I combine these two? I'm going to write it in a different color. How would I combine these two? Most people, I don't know about most, but a lot of people for sure are going to write this as log base 5 of 3x plus 1 cubed over 2x minus 1 squared divided by x. And this is wrong. And not only that, what they're going to say is, well, I have division over division, so what is going to happen to this is that this is going to go up here, and then this is going to become log base 5 of x, 3x plus 1 cubed, 2x minus 1 squared. And this is still wrong. And the reason it's wrong is because this is not what happens when we subtract logs like this. when we subtract logs like this x is just going to go under here. And let me rewrite, and this is really easiest to explain by rewriting this log. I'm going to rewrite this log as the addition of two logs. And I'm going to do that by distributing this minus sign. Let me do that in a different color. I'm going to distribute this minus sign to this x. I'm going to write this as positive log of x to the minus first. And x to the minus first is equal to 1 over x. So what I'm going to do is turn this into an addition problem. This isn't necessary, but it's easier to see why this answer is wrong by doing this. So plus the log of x to the minus 1. And now I'm going to combine these, which is going to be x to the minus 1 times this term. So log base 5, about 3. And x to the minus first is the same as this. This times this term is just going to leave an x in the denominator, which is the correct answer. So this is the correct answer. So now it's easier to see when there is a subtraction like this, subtracting a log, when there's already a division taking place, this x just gets added underneath the divisor. And I explained it by saying, well, a minus log really is just whatever this x is here to the minus power. And then we can multiply them together. So if you make that mistake often, you can convert these minus logs into positive logs by just taking the minus power out. It's just an x to the minus power. So it can be rewritten as that. But the main thing really of this problem was to explain that when there are two minuses in a row, it's not a massive log sandwich like this. There is no sandwiches. It is not tasty at all. No sandwiches are taking place. It is just adding to the divisor.